From decoding the human brain to uncovering ancient civilizations buried for millennia, artificial intelligence has become the ultimate detective of the modern age. It's cracking puzzles that baffled humanity for generations, rewriting science, medicine, and history itself. So buckle up. Today, we're counting down the top 12 real-world mysteries solved by AI. For half a century, scientists struggled with a fundamental question: how does a linear string of amino acids twist itself into a precise three-dimensional structure that defines life itself? This protein folding problem was called the Mount Everest of biology. Without solving it, we couldn't truly understand how diseases worked or how to design new drugs that interact with proteins at the molecular level. Then came DeepMind's AlphaFold. In 2021, AlphaFold predicted the three-dimensional structure of nearly 200 million proteins, covering almost every known organism on Earth. What was expected to take humanity a century took the AI just a few years. These models now accelerate drug discovery, vaccine research, and enzyme design. AlphaFold didn't just make biology faster, it made it predictable. As Nature called it, a solution to a 50-year grand challenge. In 2024, a team at the University of Texas at Austin achieved something out of science fiction. They trained AI to translate brain activity into words. Volunteers listened to stories inside an fMRI scanner. The AI watched their brain patterns and reconstructed the stories, nearly word for word. Across the ocean, Japanese researchers took a step further, training neural models to recreate images directly from thoughts. We're not talking about mind reading, but for the first time, scientists could visualize how the brain turns thoughts into language and vision. Published in Nature Neuroscience, it's one of the biggest leaps toward understanding human consciousness itself. For a century, the mysterious Nazca lines etched into Peru's desert baffled archaeologists. Who made them? Why? How many even exist? In 2023, AI changed the game. Researchers from Yamagata University fed thousands of high-resolution aerial photos into a deep learning model that scanned every inch of desert terrain. The result? Over 300 new geoglyphs discovered, nearly doubling the number previously known. Some depict humans, birds, cats, and hybrid mythological creatures that had faded to near invisibility. This discovery hints that the Nazca lines may have been ritual maps or pilgrimage guides, revealing a sophisticated spiritual landscape we never fully grasped. AI quite literally gave sight to archaeology. When Mount Vesuvius erupted in 79 AD, it buried the Roman city of Herculaneum, and with it, thousands of papyrus scrolls from an ancient library. The blast turned them into carbonized relics, too fragile to unroll or read. For nearly 2 millennia, those texts were considered lost forever. Enter the Vesuvius Challenge in 2024, a global competition uniting historians, coders, and AI experts. Using ultra-high-resolution X-ray scans and machine learning texture analysis, teams trained AI to detect minute surface differences, revealing faint ink patterns. The first deciphered passages spoke of pleasure and philosophy, echoes of lost Greek thought. Verified by BBC, MIT Tech Review, and Nature, this marks the first time in history that AI resurrected words unread for 2,000 years. Ancient inscriptions, worn by time, often contain missing words or sentences, holes in the record of human civilization. AI has started filling those gaps. Models like Pythia and Ithaca, developed by Oxford University and DeepMind, studied tens of thousands of Greek and Latin inscriptions. The systems now predict missing words with over 70% accuracy. That means AI can recreate what someone may have written 2,000 years ago, line by line. It's not rewriting history, it's restoring it. Every missing word is a voice reclaimed from silence. The deserts of Arabia, the jungles of the Amazon. For centuries, they hid entire civilizations beneath sand and soil. In 2024, archaeologists armed with AI began to see what human eyes never could. By feeding satellite and LiDAR data into deep learning systems, scientists detected patterns invisible to the naked eye: roads, walls, temples, even buried towns. A study in Nature Human Behavior revealed pre-Islamic caravan cities beneath the Arabian sands. Another, in archaeological prospection, found dozens of lost Amazonian villages hidden under rainforest canopy. AI turned wilderness into a digital time machine, mapping humanity's forgotten footprints. In Xi'an, China, the Terracotta Army stands guard over the tomb of Emperor Qin Shi Huang. Thousands of clay soldiers, each unique, have survived more than 2 millennia. But how were they made? What colors once adorned their armor? What lies beneath the tomb, still sealed from human entry? Researchers combined AI with spectroscopy to analyze microscopic pigment traces and chemical residues in soil samples. The AI detected subtle signatures revealing the original pigments and preservation techniques, even hinting at underground structures yet undiscovered. Published in Scientific Reports in 2024, these studies give the clearest glimpse yet into ancient Chinese craftsmanship, bridging technology and archaeology in one breathtaking synthesis. Every year, antibiotic resistance kills 1.3 million people, according to the World Health Organization. Humanity's medicine cabinet was running dry, until AI found something new. At MIT and Google DeepMind, researchers trained models to screen millions of molecules for antibacterial potential. In under 48 hours, the AI discovered a compound named halicin, effective against bacteria that defy every known treatment. The discovery, detailed in Nature Chemical Biology, didn't just add another drug. It redefined how we find them. AI compressed decades of trial and error into days, pointing to a future where medical discovery moves at digital speed. Every smartphone user knows the frustration. A battery that dies early, charges slowly, or fails in cold weather. The cause lies deep inside, at the atomic level of battery nanocrystals. For years, scientists couldn't see how ions moved within those crystals, or why they degraded. In 2024, researchers from Columbia University and DeepMind used AI to model and visualize the real-time structure of lithium-ion crystals, uncovering why performance drops and how to fix it. The breakthrough could lead to longer-lasting electric vehicles, faster charging devices, and greener energy storage, powered by insight only AI could see. Beyond our galaxy lies a vast, invisible structure called the cosmic web, filaments of dark matter connecting galaxies like strands of a universal spider's web. Astronomers could theorize its shape, but never truly map it. That changed when scientists at Princeton and ETH Zurich trained neural networks on simulations of the early universe. The AI reconstructed the dark matter distribution that matches observable galaxies with staggering accuracy. For the first time, we can visualize the skeleton of the cosmos itself. AI didn't just look at space, it revealed the architecture of existence. Earth's climate is a chaotic system of ocean currents, winds, clouds, and radiation. Even supercomputers struggle to predict how all the pieces interact. AI is beginning to solve it. Google's GraphCast and NVIDIA's Earth 2 models now outperform traditional meteorological forecasts, predicting extreme weather events and temperature changes days earlier and with finer resolution. These systems learn patterns too complex for any human or equation, offering new tools to anticipate hurricanes, droughts, and floods before they strike. For the first time, we're not just reacting to the climate, we're beginning to decode it. The double helix holds humanity's story, but ancient DNA is often fragmented, contaminated, or unreadable. AI models trained on modern genomes can now reconstruct entire sequences from degraded samples, allowing scientists to identify species, trace migrations, and even resurrect extinct gene variants. In 2025, researchers at Harvard and the Max Planck Institute used AI to fill in missing gaps from Neanderthal genomes, uncovering new evolutionary links to modern humans. It's the ultimate historical detective story. life itself decoded by intelligence built from silicon. From protein structures to planetary systems, from ancient scrolls to neural signals, AI is not replacing curiosity, it's amplifying it. These 12 breakthroughs remind us that intelligence isn't only biological, it's a partnership between human imagination and machine precision. AI doesn't just compute, it illuminates. It helps us read what time erased, see what light can't reach, and understand what was once unknowable. The mysteries of the world aren't vanishing. They're being rewritten in code. And as AI continues to evolve, the next great discovery might not come from a lab or a dig site, but from a line of data teaching us to see the universe anew.